It's my pleasure to welcome you all to today's session. Today we have with us Dr. Nirupa Chauhan, the Assistant Professor from the Department of Professional Accounting and Finance. I'm really honored to welcome you, ma'am, today. I would like to introduce ma'am to the audience. She is an academician and a professional with an expertise in project development and management. Ma'am currently serves in the Professional Accounting and Finance Department. She holds a PhD in management from the University of Mysore and MPhil in management from Christ University. With more than 7 years of academic experience teaching statistics, operation management, investment management, and data analysis, and 8 years of industry experience into project monitoring and scheduling, ma'am is a much sought after resource person. Her strong analytical skills using the Excel, Power BI, Amos, and R, it all will be helping us today in understanding the practical data analysis strategy. Ma'am, we look forward to a stimulating session and learn from your insights. I request you to take over the session.
Thank you so much, Renu ma'am. Without any further ado, I would like to start with today's session with the introduction of R for today, and tomorrow we will have the continuation with the bibliometric analysis. As you all know, R is one of the most strong tool than Python when we talk about the analytics. It's very strong into statistics as well as the data modeling part. So let's have a start on the introduction, and then we develop more into it, that how the various kind of problems are being solved with the help of R modeling. So I'm just sharing my screen with you. Uh, Kindly please confirm, is my screen visible to you all?
Yes, ma'am.
Yeah, thank you. So as R is being said, it is one of the integrated programming language which is being used especially for the statistical computing, data analysis, and visualization. R language is an open source. It means we do not need any kind of license. It is being circulated, and with the help of a large community support, it is being developing every day, every other day. So R provides structured approach for data manipulation, along with a decent number of memories, libraries, and packages like DPLR, ggplot for the plotting and visualization, Shiny, Janitor, bibliography, and more. So as you can see over here, when we talk about the R tutorial, it is a complete statistical language, a very strong uh, backend towards the coding part. It has a vast community because it is an open source, and various people put their efforts into it for the development. It has having more than 2000 plus free libraries which are easily downloadable. It is cross-platform compatible, whether you're iOS or Android. It is being or Linux. It is being easily accessible to all. It is being connected with various other languages, not only with English but various others also. It is easy to learn, and basically it has the best, excellent graphical outputs that we are going to see it today. So why to choose R? One of the best benefit of choosing R is because it is free and open source. So it is open for everyone, meaning users can modify, share, and contribute their work freely. Designed for data analysis, offer a comprehensive set of tools for statistical computing as well as the graphics. It has the largest repository, which is called as CRAN, Comprehensive R Archive Network, offer thousands of add-on packages for the specialized tasks. It has a cross platform compatibility, like it is being supported by Windows, Mac, Linux operating systems. And as I told you, it has a great visualization with the help of ggplot. R make it more creative, informative, and interactive charts and plots. So if we look forward for the statistical application, we knew it almost everywhere statistical is being used. Like from thinking of that I would like to buy a mobile phone. It is not a search on the Amazon, but if you look forward for down the lane, Amazon provide you different kind of viewing sections or review sections of various mobile. This is further called as a research, in which you are having a comparison that with respect to this much of amount, what is the best search which is being available. So when we look forward for the application of R, not only into data analytics, it is good with the statistical modeling as well as machine learning tasks. It is helpful in financial analysis. It is in healthcare. Clinical research is being performed in academia. Researchers and statisticians are using R for the various data analysis which is being collected through the social sciences project, and which are quite helpful in publishing the reproducible research that we have it. So if you have looked forward for the various research which are being published on bibliometric analysis, which is one of the comprehensive way of putting up of the data into in like a review of literature, one of the best way of having a compilation is with the help of bibliometrics. In the same way, we can perform d-metal analysis, or let's say fuzzy logic. These kind of analysis are being performed with the help of R. It means you just need to have a structured data and need to understand that how to perform it further. So as I told you, it is being backend by the various codings. So what are the advantages? It is compatible, it is highly extendable, as well as it is having the open source. Disadvantages, it has memory intensive because it is open source, so every another day people are putting up their information for the same, which makes as a difficult to be operate on. Limited support for the error handling because it is not a closed loop. Various people are working on it, because of which the robust error handling features are missing into it. This has a steeper learning curve. Beginners might face a bit challenge with the some of the R's complex features and the syntax, and the people who are having the bit of understanding about the coding, they feel it bit easier to learn R programming. It's not difficult, but only thing is a bit of understanding about, if you have the coding understanding or the syntax understanding, if you have it, then the learning of this language become more easier. So it has lagged behind language like Python, which is being called as a user friendly software. Here it is with the help of syntax as well as the code, if it's not being run properly, we will find the error for the same. So when we are performing the large scale operations, especially in R, we always found it a disadvantage compared to Python. So let's see how to install R and R Studio. So when we are working on R, there are two software packages which are being needed. One is called as R and second called as R Studio. So here you can see that this is open and download and install, which is a poised.do. It is an open source. From there, it can easily be downloaded. As you put the on your search engine, as you put R Studio, you will get these kind of information. Poised, you can download R Studio desktop, and then further, first is download and install R. Once you install R, then you have the install R Studio. So both the directories has to be installed when you are working for the R package. And then this one. So as it's keep on upgrading now and then, so most of the time, what are the refreshments that are happening? It's keep on updating by itself. So let's see how it works. So I'm opening the R engine. Ma'am, can you please confirm my R Studio is visible to you all?
I don't think, ma'am. It's still
Okay.
your PPT only.
Okay, ma'am. So let me switch my my screen, ma'am. Yeah. Now is it visible, ma'am? My working window
Yes,
is
ma'am.
visible.
Yes,
Yeah,
ma'am.
sure,
Yes.
sure. Thank you. So now as we are entering into how to work on the very first code, we are going to look forward for that how the R works on the print function. So let's have it. So what I'm doing is I'm writing a code on print hello world, and the code is print hello world. That is a very first basic function that we put it. And as we enter the first code, it says that hello world. So most of the time when we are starting the code, we start with the hello world. And then, so before we are putting it up, it is important to understand that what kind of data structures which are being supported by this platform. I'll show you that what are the support functions that we have it. So the data structure in these sections are vectors, list, matrices, data frames, and arrays, factors, and strings. So these are being supported by here. So data structure in R programming, as you can see over there, X, it is a vector, right? This first part is vector in which into an array you have written that C13578, and I would like to print C. It means it's a data set, right? I'm having certain data set and I would like to print it further. So what I'm going to do is I'm going to copy this command, and I'm switching my screen, the same one, and I'm putting it over here. I would like to print this complete, and I'm giving the command as, so it will, how it will print? It will print as 13578 rather than the complete one. So how much that you want to get it printed, it will get reflected over here. This is called as the very first code or vectors that we have it. Then the second one is called as list. Right now, this is being highly used when the people are working into HR field, right? So now, if you can see the code over here, what we want to, a list of generic object consisting an ordered collection of data. List of our heterogeneous data structure. They are not one dimensional. They can be list of vectors, list of matrices, list of characters, and list of function, and so on. So now please understand this, that I'm having certain employee code, which I've written as 1, 2, 3, 4. And under that, employee names are also there. Debbie, Sandeep, Shubham, and Shiba. Number of employees which are being given over there as 4. And I would like to make a list. A list how I want to. I would like to make into the listing like employee ID, employee name, and number of employees. So I would like to generate it. So when the people are working, especially into HR field and all, and where they would like to see that you are having certain codes are there, and you would like to see who are the people under that code, right, under that section, who are the under that employee ID, who are the people are there. So you just have to get that .csv file on your R system, and it will help you to get the data from there. How does it work? So let's go on the worksheet. Here I am putting it up, employee ID. I put the employee name, number of employees, and employee list. So as I put the enter, how it is going to do it? It has done. One is 1, 2, 3, 4. Then second command which I have given, I would like to know who are there at 1, 2, 3, 4. They have given the listing for the same. And the last answer I've asked him that number of employees are how many. It has given me that also. Right? So this is also one of the listing that we have it. The third part, I'm sorry, I have to keep on shifting my screen. Now, third part is called as data frames. Now, data frames are generic data objects of R, which are being used to store the data into the tabular data. Now, now you have seen that we are having into the horizontal line, but into the vertical line when we are using it, we are using the data frames. So the data frames are the most popular data objects in R programming because we are comfortable in seeing the data into the tabular form. These are two-dimensional. These are heterogeneous data structure, and these are having the vectors equal to the lengths. So how the data frames are? The data frame must be in column names. Like it is like your Excel sheet, column as well as rows. Each column must have the identifier number of the item. They should have single column must be the same data type. Different columns should be for the different data types. And we are using the data frame function. As you can see it, I have put it as a red. So that to create a data frame, we use data frame function. So now let's see this. I have put a code. I'm having a name. I would like to see that Amya, Raj, and Amish, they are learning different kind of languages and what are their age. And I would like to make them into a data frame. Just a moment, please. So I have put the command over here, name, C, in semicolons, all the names has been written. Language, what are they learning? Age, C again, what their ages, and how I would like to get my output. So here you can see that on the top, you have seen that we were having the horizontal data structure. Now I have made a frame in which name has been classified under one column, language, what they are learning has been classified under one column, and what is their age has also been classified as one column. So this is the various ways of the data representation of the data structure that we have it. The next one is called as matrix. So a matrix is a rectangular arrangement of the number in the row and columns. So we know that rows are being run horizontally and columns are being run vertically. So matrix are two-dimensional and homogeneous data structure. So now here you can see that I'm having AA matrix where C is equal to till 9. I'm having arrow number of rows should be 3 and number of columns should be 3. It means how by 1, 2, 3, 4, 5, 6, 7, 8, 9 which are being written, they should be printed into a matrix, 3 by 3 column matrix it should be printed. So how I'm going to work it on? So I'm giving the complete command over there, right? So I would like to have a matrix 3 by 3, 3 into 3 matrix should be there. My number should be 3 should be there in the row and 3 should be there into the column. So as much as big your data structure is, you can classify it further. Let's say you are having the complete data into Word format, right? And there you would like to see that I would like to create the matrix that this complete data structure should be arranged into row and column with the matrix of 4 by 5. It can easily be done with the help of R matrix. So here I'm giving the command. I'm writing the matrix over there by row and columns, as you can see it over there. So, sorry, I have an error print 8. Just a moment. Let me just complete it. Here you can see that there was double A was there, because of which that error has happened. As you can see it over here, only one mistake, right? The mistake was triple A. Here you can see this matrix, triple A is equal to matrix, right? And I am writing print A, right? So what is it has to read? It has to read either it has to read triple A, double A, sorry, or it has to, or this double A should be replaced as A. So as I'm telling, it is very much case sensitive. So if you are having certain kind of nomenclature missing, then you will always found the error into it, right? So here you can see that matrix, it has completed have into the matrix one, but error is there in is equal to error is there, which cannot be resolved at this moment of time because we have to have further matrix for the same. Now let's move ahead with another data structure which is being used into data analytics, that is called as array. Now, what are arrays? Arrays are the data structure more than 2 dimensions. These are n-dimensional data structure. For example, if we create an array of dimension 2, 3, 3, then it will create 3 rectangular matrix, each with 2 row and 3 column, right? So these are the homogeneous data structure that we have it. Let's see how it will be get created. What I'm doing is I am writing an array where 8 words are there and each dimension is for 2, 2, 2. I want to create an array with the same. Sorry, please, this is not the array. Just a minute. Sorry, the command has not been copied. So here, as I'm printing the array, you can see that what I have done in this complete data, that was 1, 2, 3, 4, 5, 6, 8. But I would like to have it. I would like to have 2 and 2, 2 into 2 matrix. I would like to have it. So what they have done, they have classified into 2 and 2 clustering. This is called as the array clustering that we have. Then further, we have the factors, right? So factors are the data objects which are being used to categorize the data at store in as its levels. These are useful for sorting of the data into the categorical method. So these are used strings also as integers also. So strings are nothing but the words and integers are numbers. So they are useful to categorize unique kind of values into columns like true or false, male or female, etc. So they are being useful in data analysis for the statistical modeling. So let's create one of the factor using factor as C, male, female, male, 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 female, and male. So let's create a factor with that. So I'm creating a factor with these data structure. So here what has been done, it has make a different kind of structure that we have male, female, then male, male, female, male, female, and levels are male. So here how much categories that we have is we are having only 2 categories. So let's say you are having different kind of categories that you have. Let's say you are collecting our data for first to 10th standard students, right? So you will having different kind of standards that we have it, and for that one different number of students will be representing that class. So with the help of this, what I can do is I can create the factor that for first class how many number of students are there. So it will classify that first standard this many number of students, second standard this many number of students, right? Rather than having a summing up of all the information, as you put it over there, it will create a factor for you. So this is the factors that we have on the R. Then we have tables. Now, tables are an enhanced version of data frames, which are being called as tidyverse. And for that, when we are working on tidyverse, we have to install the library. So as you can see this is the table library. So let's say if you have to work on the table or tidyverse, you have to first install this library. These are inbuilt R libraries, but when we are working into the advanced statistical version, we have to recall or we have to recall these kind of libraries from the R. So we keep on first install these libraries which are inbuilt in R, and then only we keep on working. So they offer the improved printing, stricter column types, consistent subsetting behavior, and allow variable to be referred as objects. So tables provide a modern user-friendly approach to the tabular format. So I'll show you how it will be. So I'm having a data, I'm having name, I'm having their age, and I'm having their which place do they belongs to. So I would like to have a classification for the same. And before proceeding, as I've told you, I have to install the library first. So once ever you are working on this, one thing is whatsoever data structure you have it, you have to install the library. As you can see over here, I put my library table. So now I'm good to work on it. So I'm doing the tabular, putting over here. I would like to have a classification, print my data. Now how my data has got printed: name, char, right? These are the characters that we have it. Then age, these are the numbers. And then we have city also. These are being into characteristics. So what we have done, the complete data with the help of table, we have given into the complete row and column format in which name, age, and city wise, they have classified it. This is also one of the way of data presentation that we have on R. Now, before we are moving ahead and doing a small exercise on data statistics, let's understand how R is being used into the statistical analysis. So R is an tool which is having the inbuilt functions like mean, median, mode, statistical deviation, standard deviation, variance, correlation, regression, everything they have the inbuilt function. Only thing is we have to call the directories for the same, and it help into supporting of the complex data that we have it. So it allows the users to perform everything from basic descriptive statistics like mean, median, mode, but to advanced modeling with the minimal code. Let's say if you have to perform a Pearson correlation, right? Or let's say you have to perform a standard deviation. You don't have to write the formula. You just have to write std.dev, and you have to just put the data set, and it will keep on working for the same. So it is, and with the help of that also, if you like to see the visual depiction for the same, you can make the visualization also with the help of this software. We can also perform the probabilities like 0 and 150-50%. We can have the certainties which can be performed with the help of the real world events, right? So let's say you have a coin and you flip it over and you would like to see what are the chances of having the 10 tens, right, in the 2 chances. This can also be performed with the help of the R function. So as you know that when we are working on the probability distribution, there are 4 ways that we have it. One is called as uniform distribution, like center of tendency, right, which are uniformly distributed. Then we have normal distribution, which is called as symmetrical bell curve characterized by mean and standard deviations. Then we have binomial distribution, describe the number of successes in a fixed number of independent Bernoulli's trials. And then we have the Poisson distribution that models the number of events occurring in a fixed interval and the fixed time space. Let's say you are into a box and you would like to understand that how many times this particular event will happen. That moment of time we are understanding the Poisson distribution. So let's go with this one. So I'm going to plot something which is called as a sequential plot 4 by 4. So and in there, because it's a visualization, the plotting how I would like to see the line into blue color, and I would like to see the density, how it will be circulated for the same. So as you can see there, for the visualization, very first library that is being needed is the ggplot, which is an inbuilt library, but we have to call it first. So I'm copying this. Let's go to our studio. So I'm copying the library. I'm calling the library. So it is as you can see, I'm getting the warning message that it is a inbuilt under the R version 4.4.3. So it is already being, because I was working on it. So it's already being there with me. Let me just have a complete screen. So let's have just a small place. So let me get the code. So here you can see, as what I want to, as I've told you, ggplot, what? It is a visualization. Here you can see what I have done. I would like to have the line in my blue color, right? And what I would like to do, I would like to plot mean as 0, right? And standard deviation as 1. So it is a normal distribution that I want to have it. So what I have done, I would like to plot dnorm x mean 0, standard deviation as 1, plot on x and y frame, x and y axis, and ggplot, and the line color should be blue. Subtitles, normal distribution, x is equal to x and y is the density, and we have plotted it. So this is the quick data visualization that we have it with the help of data structure. So let's see another one. Then visualization is gaining insights from probability in R, and it offers numerous packages like ggplot, lattice, and basic graphics for creating the visualizations. Common plots like histograms, density plots, box plots, scatter plots, which are big, or let's say then bubble plots and all, can easily be created with the help of visualization. Now let's do another question, that is the flip of coin, right? So I'm having, let's say I'm having 100, size is 10, and chance of occurrence is 0.5. So 50% chance of occurrence is there. I would like to plot an histogram. So histogram will be hist, flip, break, sequence should be 10.5 by 1, color should be light green. But I'm going to do a binomial distribution by flipping the cone, because I don't know how many flips it will come, and I need to know x of heads, and y will be y on the x lab will be head, x lab will be head, and on y side I will having the frequency. So let's, so the histogram which I'm going to show and which we are going to put it up, it is for the 100 trials, right? So we are because here I'm writing that 100 trials, sorry, I'm sorry, 1,000 trials, and flipping of the coin, and 10 times the fair coin should come. So most it will center about 5 heads, forming a symmetric bell-shaped curve. So this is the code that has been written. Let's go with R. I'll just here I am writing it. So yeah, you can see that this is the binomial distribution of the flip of the coins. Here I've done it, like there is the number of head 10 times, which you have seen there, which has been written, right? Size of 10 heads, right? And there we have written the frequency, right? So 250 times we have done it. So how many times the heads has occurred, and what we have said, the chances of occurrence are 50%. So we have equally distributed the complete data set, and binomial distribution of coin flips has happened, and the color of my graphs or my histogram should be there into green color, which I have notified, and it has been done. This is how the binomial distribution visualization can be done with the help of R. Then the another one that we have, this is the flip of coin. Then we have, now we are coming up ahead with the statistical tools that are being done with the help of R programming. So as you know that the base of any data set structure is the central of tendency, that is called as mean, median, mode. And these all operations can easily be performed with the help of R. So these are the inbuilt moderation that we have it. It is important to summarize and understand the center of tendency for the data set, that we should not have a skewness of the curtices, that my curve is not moving towards right hand side or left hand side. I should have an equal distribution of the data. And for that, we study all the three, the mean, median, mode of the center of tendency, right? With the help of R programming, we are able to see also that the data which we are using for our analysis, is it skewed or it is equally or the normally distributed. So as you can see now here, I've just written a small code that there I'm having a data structure that is X is equal to C 2, 4, 6, 8, 10, right? So if I ask you, so how are you going to do it? So it is very, you will say very simple, right? It is independent data sets, 2 for 4 plus 6 plus 8 plus 10 and divide by 5, because number of observations are 5, and we get the mean for the same. But if we have a numerous, or let's say 1,000 data is there, then we just need to have these X value and just copy this, and this is just, you have to just write X and the complete string that you have to write it, and you have to just cite mean as X and go to your R platform right over there and see the mean for the same is 6, right? So when you do it, 2 for 4, 6, 6 plus 6, 12, 6, 12, and 8, 20, and 10, 30, and divide by 5, mean is 6. But if I'm having the data set of 1,000 of values, that will become a bit difficult, right? So quite easily, if you have written C, you have done the complete code, quite easily you can perform it. This is the easy function. Then the second part that we have is median, right? So now if I ask you find the median part over here, right? So as you know here, if I ask you what is the median, you will say that like mid is 5, right? So and this data is being arranged properly. So let's, if we put up over there and find the median, so median will be 5 because it is a odd data set, and we know that mid value, right? So it will be this one. Then we are having the another one, central tendency, that is called as the mode, which is the value which is highly repeated that we have it. So to get the mode, now to get the mode, very first is we have to go for the function. We have to call the function for the first, right? So get mode, we have to call the function, and then I'm having it. So as you can see, my data structure is X is equal to 1, 2, 2, 3, 3, 3, and 4. Now if I ask you what is the mode over here, you can clearly say that it is 3. Nirupa, it is 3 because 3 has been repeated multiple times, right? But in the machine, if you have in your CSV file, you have called a complete CSV file, and you would like to see what is the mode over there, right? So you just have to copy that column, and you have to get mode as X. You will get the mode of that data structure. So let's see. So here when I'm putting it up, find, sorry, yes, median again, I'm sorry. So I've written the function, unique function of for V, and I'm looking forward for the mode for the same. And here, because 3 has been repeated maximum time, so we are having the mode as 3. So these are the basic function that is being used when we are performing the statistics. Then we have the variance. Now we are moving a bit ahead. Variance, as you know, that is the square of variance is standard deviation. So standard deviation is under root of variance. Or and then we talk about, when we talk about variance, that if you remember that we are talking about that how much the deviation of the individual value is there from the mean value, right? And the square of the same divided by number of observations. From there, we found the variance as well as standard deviation. But if I have to go with that much of calculation, my time will be get consumed a lot. Rather than I'm having a data structure, you just write, take the list of elements. I am taking the list that is 2, 4, 4, 4, 5, 5, and 7, 9. And I would like to calculate the variance with the help of var as closed column or the closed brackets. I'm copying this. Yes. And here I'm writing the code, and there the variance is 4.57149. So if we have to calculate the variance, very first is we have to calculate the mean, then we have to calculate the deviation, then we have to square of deviation, then sum of that divided by number of observation and under root, we will get this. It will, if we don't get the under root, then we have the variance for the same. Rather than doing and so much of hefty task, you have just got the list of data and put it up, calculate the variance using the VAR close brackets and print variance as a list. Like list is this data set, right? This data set is a list, and print that, and you will get the answer. Now another one, let's see how to calculate the standard deviation on the same one. So let's have it. So here in the same data structure. So if you are putting up under root of 4.571429, because the data structure is same, we are getting the deviation, right? So with just what we are doing, I'm having a list, right? Or you can write X also, X, and you are having the complete list of numbers, and from there deviation using SD close brackets and print SD of the list, right? And the automatically with the help of the function inbuilt, the standard deviation for the same will be calculated. So these are the basic functions that is being used when we are performing the descriptive analysis. Now let's see that. So now if I would like to calculate all the same into one data set. So what we have done so far, we have calculated it individually. Now I'm having a data set, and for the same, I would like to calculate the mean also, variance also, and the standard deviation also in one shot. So you can write it. So calculate mean with the mean, the data name is data, right? And I'm having the data set, calculate mean, calculate variance, and calculate standard deviation. So in the one data set, all the three or multiple measures can be calculated. So let's put it over here. So as I am putting the code, as I'm putting the code over here, calculate mean, calculate variance, as well as calculate standard deviation. So here you can see that individually, right? What is there individually? My data for the mean has been calculated, variance has been calculated, as well as standard deviation has been calculated. Only thing is that you are having the data set and you have written the code that all the three should be calculated in one shot. Now let's understand. So far we have seen the calculation. Now let's have the visualization of these mean, variance, and standard deviation together. And for that one, we can visualize these measures using the density plot with the help of ggplot. Right, so this we have to install it first. So there is first is I have to install this library, right? So I'm just install. So first I will make you understand this complete coding, and then we'll perform the complete run on the R. So very first is I have to install the library, that is library ggplot2, because it's already is there on my machine. So it will give me the error, because it will give me a warning sign. It's already made there. But if you are doing it for a very first time, it will install all the functions for the ggplot for you. Then I'm generating the data set of random 10 data points with the mean of 50 and set standard deviation of 10, right? And they are normally distributed at 100, 50, and 10. And for that, I would like to calculate the mean, variance, and the standard deviation. Now, because I am plotting it up, I have to further clarify it, that what kind of column color should be there, what should be there on x-axis and y-axis, how my data visualization should be there. That kind of code also I have to give. So what I have to give, add vertical lines for the mean and standard deviation boundaries, and then we have having the intercepts. Color should be red, green, and green. Line time should be dashed, dotted, and then width should be 1 pointer. So you can specify it as per your requirement. And then the title of the tab should be mean, variance, and standard deviation, and data type should be y, should be my density, right? So here what I have done the annotation. Mean should be red, and then my standard deviation should be green, and then my variation should be blue, right? So let's have the complete code, so that for have the visualization, right? So very first thing, I'm installing the library first for you so that I can show you how does it really reflect. So here the library is installed. Then I'm taking the complete code that has been written, that what are the width, what kind of color I would like to have for my 100 random data. I'm putting the code over here. So here red, green and blue codings are there. So now kindly please see, right? So the random 100 data that we have it, and we have made the standard deviation, right, as well as mean we have done, and the complete array has been shown with the help of variance. So the variance over here, the calculation of variance is 83.3, and the mean deviation, how much it is varying for, as you can see that I'm having a kurtosis data because it is being bent towards the right hand side, right? So this side I'm having 60.6303 and this side I'm having 40.78, and the mean is 50.09 for the data set of 100 random values. So you have not only have done the calculation, but you also have plotted it and have a visualization scenario also. Now let's understand the further of the codes. So these are the very basic center of tendencies problem that we have done it, but statistics are far more ahead. So what we are going to do it now, we are going to see how the t-test, z-test, or let's say f-test or chi-square can be performed on the R software. So let's have a t-test first, and we are going to have the simple t-test to test my hypothesis. So the t-test is used to compare the mean and the test hypothesis about the population mean. So it assumes the data is approximately normally distributed and come in three forms: one sample, two sample independent, and pair t-test. So we are performing the one sample t-test. So one sample t-test is check if the mean of my sample is different from the hypothesized value. So how it will be done? So let's say example, I would like to see that check if the mean of my given sample is equivalent to 28 or not, right? We are testing whether the sample mean, this sample mean which I'm having is whether the mean of this is 28 or not, that I want to check it, right? So I'm performing a t-test. So let me have my workplace. Yes. Sorry. Wait. So I'm performing a t-test now. Here you have seen I have put the random data, and I would like to see whether the mean for the same is 28 or not. And for that, I'm performing the t-test. So here the answer is 28.42857, right? It means that it is not equal to 28. So my hypothesis is being rejected. My hypothesis was that these are same, but it's not. So it is being rejected, right? But if you see 95 percentile of interval level, it should be in between 25.99 to 30.86. You don't remember, no, 0.968 that we have the variation to 95% percentile of the confidence level, right? So there it is 28.428. If I'm not looking forward for the exact number, then yes, it is like my null hypothesis is accepted, that there is no difference between the assumed mean of the sample versus the which I have called for. So what I have hypothesized, the data set which I'm taking is having the mean of 28, and by seeing it here, I'm getting 28.42, which is the variation which is coming up under the 95% confidence interval, right? So my hypothesis, the null hypothesis, that yes, there is the sample mean as well as hypothesized mean is equal, it is being accepted. Now let's see the another test. Now let's have a two sample t-test in which I would like to test the two different independent groups. I would like to see that whether the mean of these two groups are same or different. So used to compare the mean of two independent groups, the X and Y. The example, the two sample t set compare the mean of group 1 and group 2 and to see if they are different or are they same. So if they are different, then we accept our alternate hypothesis. But if they are same, then we are accepting our null hypothesis, right? So group 1 is this, group 2 is this. I would like to see whether the t-test, the mean value of these two groups are same or different. So group 1 has been given, group 2 has been given. I'm performing the t-test to check the mean of these two data sets. So here, as you can see that we have performed the two sample test. T minus 6, degree of freedom is 8, p value is 0.0032237 with the 0.01 p level, 95% confidence level, mean is 20, second mean is 26. So what we are doing is two difference. So we are accepting our alternate hypothesis that the two means of the groups are different, right? So let's see the another data structure. Paired. When we talk about the paired t-test, so it is used to compare the mean of same group at different times, or the two different countries, right, or two different conditions that we have it. So we all would like to have a check for the same. So the paired t-test compare before and after values. Let's say you are having blood test, sugar blood test, right? So before before the fasting and after test, after starving, after my fasting, I would like to see what is the change into my blood test, or I would like to see what is the difference into my sugar level. So that is called as a pair t test. So I would like to see whether the kind of significance difference is there or not. So before and after, and I would like to see what is the difference between these two. Let's say before my if you are having, anybody is having fear from injection. So before my injection, I'm having this much of my heart pulse rate, and after my injection, this is my pulse rate. So are they same or not? It means in the whether I am a scared person or not. That can also be tested when both the mean value will be same. But if it is different, then I'm accepting my alternate hypothesis that before injection my heart rate is too different, and after my injection the heart rate is different. So I have to test it. This is called as paired t-test. So here we just put it up before your data set, after your data set, and result should be t-test before and after, paired and true value. So here you can see this, right? So there you can see alternate hypothesis that true mean difference is not equal to 0, right? So there is no difference. So these are the normal statistical tests which are being used into our data sets are being performed. So let's have ANOVA. Right? So ANOVA is nothing but when we have three three groups are there, and we would like to check the differences between these two, which is called as analysis of variance. So I would like to see the mean of A, B, and C or more independent groups to determine if they are statistically significant difference or not, right? So what we are doing it here, we are comparing the mean across the multiple groups using the formula interface. Now here, as you can see that factors are there, A, B, and C, and each are having 5 values. These are the sources that we have it, and I would like to get the summary. So I would like to make the 3 groups like A, B, C, and 5 of each. So I'm having 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and 15 groups are there, and each group will be divided into 5 categories. So A will be from 80 to 84, B will be from 90 to 93, and C will be from 78 to 77. So I would like to check their scores, right? So for the variance ANOVA, I would like to perform it. So let's do it. So here, what I have done, I have performed the ANOVA, right? So degree of freedom is 2. My complete data structure has come. So what they are saying is that significance at every level, we are accepting our null hypothesis, that we are accepting it, that there is no difference in the variation between all the 3 groups. Right. Then we are having the Pearson correlation test. As you know that it's a Carl Pearson test, which is being used to understand the correlation between the two variables, right? So X and Y. So let's say I'm having X and Y, and I would like to see the correlation between the two. So if you have to perform it on manually, then we have to go under root of summation of xy divided by under root of xy divided by under root of summation of x square into summation of y square, where x and y are my deviations, right? So this much of calculation which we have to do it. As you can see, it is the individual data set. So we are, rather than performing this much of calculation, we are just writing get me the result of the correlation test x and y, and method should be Karl Pearson method. So I have specified it that under which method I would like to have the result. So they have performed Pearson product correlation. I have got my t value, degree of freedom, p value, as well as sample estimate, and there is 95%, right? As well as the result for the same has been generated. That correlation value is 1. It shows that highly correlated data set. Then we are having the F test. Now, what is F test? F test is used to compare the variances of two samples to determine whether they are different or not. So let's have the syntax for the same is variance test x and y, two different data set, and check their variance test. So variance test performs a F test to compare the variances of two groups. Like t test is being used to test the variation of mean. In the same way, F test is used to check the variances of two groups. So these are the two numeric vectors x and y. So example is that F test checks if the group 1 and group 2 are having equal variances. So let's say here variance check. So if group 1 is there and group 2 is there, I would like to see whether group 1 or group 2 are having the same variance or not. So here you are having the variance 2 ratio, variance is not equal to 1. It means the group 1 and group 2 doesn't have the same variances, right? So these are the various data structures which are being performed. Now we are having the Z test. So Z test is required to perform the difference between sample as well as population. Let's say from a population, you have taken a sample size which is less than 30. I would like to see that this sample is representation of my complete population or not. And for that, we perform the Z set. And for this, we use the another syntax that is called as BSDA, right? To test mean of my sample versus the mean of my complete population, right? So how it will be done? Let's see this. Very first thing, I have to install to perform this Z test. I have to install this package which is called as BSDA. So it is not an inbuilt package. First, you have to install it into your library. So you have to call it on your working platform. How? So here you can see. Sorry, this doesn't come. So here I have copied it, putting over there. I'm installing BSDA package. So installation is being done because it's there with me. So if you are performing this, you have to install the BSDA package first to perform this activity. As you can see it over here. So this is being installed successfully. Now I'm using the library and checking my Z test with the help of my sample versus a population value. So here as you can see that the things has been done, and true mean is not equal to 75, right? So the mean, which I've said that the mean of this data set, it is 75, right? So mean of my sample is set at 75, but when we have done it, the mean of my population is 75, but when I have tested the mean of my sample, it is not coming up to be 75. So there is a difference between. So we are rejecting the null hypothesis, stating it the mean of the sample is variance of the sample is equal to the variance of the population. That we are rejecting it here. So let's see further. So these are the basic functionality of the data analytics which are being performed using R. Right now, I hope everybody remember the Durbin-Watson test, which is being used to detect the presence of any kind of autocorrelation in the residuals of the regression analysis. So regression analysis is when we are testing the dependent and the independent variable together, right? So for that one, if there any kind of autocorrelation residuals are there, Durbin-Watson test is being performed. So again, to perform this test, you have to install the new package, which is called as IMTest. So before you are going to do the Durbin-Watson test, this library need to be installed first. So here I'm installing this. As you can see, with the help of the online library, they are installing this package. And further, I would like to test the Durbin-Watson test of these two data set. So here we have it, right? Here you can see I have performed that alternative hypothesis 2 correlation is greater than 0, right? So we have performed the Durbin-Watson data set for the regression auto correlation residual. Now let's move ahead. Just a moment. Okay. Furthermore, let's have the testing of our hypothesis. So far, we have seen how the Z test, T test, or F tests are being done. Let's have a hypothesis testing also using R. So let's say you are having a data set of the blood pressure before and after treatment you have collected, and we define that the new drug which has been given has no effect on the blood pressure, right? So before also we have tested the blood pressure, after giving the drug also we have tested the blood pressure, and we sees that my null hypothesis that there is no relationship, right? Even I've given a new drug, there is no change into the blood pressure. My alternate hypothesis is that there is some kind of change, right? And for that I need to have a data set. So before, how much is my blood pressure, and after giving the new drug, this is my blood pressure, and this need to be tested. So this is my hypothesis data. I'm putting on the workstation, right? So this is before and after treatment data set I have put up. I would like to see print null hypothesis as H_0. The new drug is no effect on the blood pressure, but if it is, then there is an effect on the blood pressure. I would like to test the hypothesis. So here you can see that it has been printed. Alternate hypothesis as well as the new hypothesis has been printed. Now, the same way you can perform the paired t-test. These are the t-test before and after true value. So when I have taken the t-test, then first is t-test perform that and give me the result on the same data structure. Now do it. First I have done the printing, and then I am performing the t-test before and after of giving the drug, and print it. So we have performed it. That true difference is 0. This is the same one, 3.9. Mean difference is 3.9, right? And my p-value is 8.538 e raised to power minus 6, right? So we accept our alternate hypothesis because we are rejecting our null hypothesis, stating it that the new drug has an effect on the blood pressure. The very first thing is we have come up with the module, and then we have tested the t-test for the same. Right. And sorry, where is my presentation? Yeah. Just a moment, please. So now, as we have done the comparing paired t-test, now finding the value. So once you have done, now I would like to get this value printed. So what first is you have put it the value as 0 and 1. On the second part, you have done the calculation, and third part, what I'm doing is print the p-value. If the print value is more than equivalent to 0.05, then reject the null hypothesis, or if it is equal, then accept the null hypothesis. So we are putting it up over there. I'm going for having a sharing platform. Share it. So now see, at very first we have classified this, and we have classified that what is my null hypothesis and alternate hypothesis. Then we have performed the t-test, the paired t-test, to get the mean difference, and now I'm testing my p-value, right? P-value I'm testing. If my value is more than 0.05, then to accept the null hypothesis, sorry, accept the alternate hypothesis that there is a significant difference of the blood pressure before and after treatment. If not, then go with the fail. So here we have, so what we are doing is, as you can see, we got the result that we are rejecting the null hypothesis that there is a significant difference in blood pressure before and after the treatment. So these are the one how we are doing the hypothesis testing also with the help of our software. Then in the same way, you can have correlation also. You can perform using R. So various studies like study hours, exam scores. I would like to see that whether more study hours, like hypothesis is that more study hours lead to have more exam scores. So I would like to test this hypothesis. This hypothesis can also be tested with the help of these. So as you can see over here, I've written the complete formula where we have put the deviations of X and Y and put it over there. And this is my data set. Right, so with the help of this, I would like to see whether study hours and exam score is having any kind of correlation and all. So I'll go to my workstation. Sorry, this is wrong. Yeah. So here I'm putting it up. I'm testing the correlation. So now here we have having the data set. Right. So now further. Right. So now with the help of these data what we have calculated can also be plotted, right? So plot, display a scatter plot of the exam score, main set up the title of the scatter plot, a line, add the straight line in the plot typically used to display the regression line, which is the relationship between dependent and independent variable. IM fit a linear regression model to the data. Call sets the color of the regression line. Text places the correlation value as text at the specified coordinates on the plot. Paste combine the data of text as the numerical values into a single string, and round the correlation value to a specified number to the decimal places. So let's plot it. So I have done the calculation. Now the complete calculation in between study hours as well as exam performance, I would like to plot it. So with this, let's do it. Sorry, I need to have RStudio. Where is my RStudio? Yeah, so here, as we are putting it up, wait. So what we are going to do it, we are going to put up plot study hours as a scatter plot, have the column as red, and plot the complete one. Why it is not being plotted? Right, so this is how it can be. Sorry. So we are having the complete visualization over here, right? So these are the ones. So we have taken it. So apart from that, so these are the plotting that we have it. Then we also can perform the single regression lines with the help of these ones. So I would like to see the impact of study hours on the exam scores with the same data. What is the impact on the same? So I'm putting up the regression. Here you can see we have made a regression model with the help of this. Furthermore, if you want to see, you can visualize this data on the regression line. That will be here. You can plot the study hours and all. Here it will be that the complete column or the green scores and all that can be plotted, right? This is how various expressions that we have on statistics can easily be performed with the help of R. So we have many more to do. These are the basic statistics that we have performed further. I would like to also do a small case study with you, but again, because of the constraint of time, I'm stopping it for today. Tomorrow, when we will meet, we will do a small case study on the sales as well as the bibliometric analysis. If any questions, please. I'm stopping my share. Yes. Thank you.
Participants, if you have any questions, you can just write the question. Yes, no, I think we can wind up. Dear Mom, thank you for providing us with a strong foundational understanding of art. Your depth of explanation and practical demonstration greatly enhanced the learning experience of all of us. We look forward to tomorrow's session with great enthusiasm. So, dear participants, there is an announcement regarding the tomorrow's session. We will be starting from 1 p.m. to 2 p.m. Thank you all for your active participation in today's session. Thank you.
Thank you so much, ma'am. Have a nice
Thank
evening.
you.
Thank you.
Kindly fill the feedback link. It's already shared in the WhatsApp group as well as in this.